my dear children. I hope you all are good at health, and I believe that you all had completed your notes up to magnets part 1. Am I right? So, last 2 classes we discussed about magnet, and you know the natural magnet, that is magnetite, and you know the some materials are magnetic materials, some are non-magnetic materials because of their power of attraction towards the magnet. And you all, another thing you know about magnet is that magnet is having the north pole and the south pole. And one more thing you are very familiar that magnet exerts more force or power at the poles only. Isn't it? Yes. So today we are going to study more properties of the magnet. Properties of what? Properties of magnet. And as we all know, magnet is having the north pole and the south pole. Some of you may think that when we cut the magnet, we may get one magnet as having north pole, another magnet having the south pole. But it's absolutely wrong. We will not get it like that. When we cut the magnet into smaller pieces, each piece is having a north pole and a south pole. Each piece is having a north pole and a south pole. I will show you that. See, these are the 2 pieces of a magnet. You know, the magnet has broken into 2 pieces. So just I will try to bring these 2 closer, but you can see that. What you can see, is it touching? No, because one is both are the north poles, because this is the north pole and this is the south pole. Similarly, this magnet is having the north pole and the south pole. Just try. See what happened? Yes, they attaches to each other. Hope it is clear. They attaches to each other. That is it. So, when we cut the magnet into so many pieces, even if the smallest piece is having what? A north pole and a south pole. Clear? So, you can see that picture on the board. When the magnet cut into different pieces, each piece is having a north pole and the south pole. That's the one property of the magnet. Next one, as we all know, magnet exerts the maximum magnetic force at the poles. Just see that maximum magnetic force at the poles, because the poles are the most attractive part. This north pole and the south pole, they are the most attractive part of a magnet. You see, the most attractive part of a magnet, they are the poles. In the poles, we can see that more attraction is there. This is another property of the magnet, that is at the poles they have the maximum magnetic property. Next one, I will show you another thing. Hope you have seen this. Clear? This is a paper cup. So I will try. See, these are the safety pin. I will try these pins to be in contact with the paper cup. Can you see what is happening here? Can this paper cup attract these pins? No. See, now this is a magnet. So what happened? Yes, I am dropping this magnet into this cup. Then see what happened. Yes. Hope it is clear. Yes, the pin gets attracted towards the magnet, but this magnet is not in close contact with the pin. The pins are in contact with this paper cup. Is it clear? The pins are in contact with the paper cup and the magnet is inside it. But when I try to remove the magnet, see what happened? See, the pins are getting separated. Clear? Then once again, see, I'm holding this magnet. So what happened? Yes, the pins are getting attracted. See, from this we could understand that magnet does not need to be in close contact with the material to get it attracted, without being in close contact. But as the distance increases, see, as the distance increases, see, the power of attract, now it is closer only, no attraction is there. But when I try to remove, yes, here we cannot, as the distance increases, power of attraction decreases. Clear? But when these pins are coming closer to the paper cup, I can feel that force of attraction. Yes, it get attracted. But as the distance increases, attraction also get what? Attraction also gets lesser and lesser. This is another property of magnet. Magnet does not need to be in close contact with the magnetic material to get it attracted. Clear that you have seen through the experiment. Another point about the magnet is that some of you may think that smaller magnets does not have what? More power of attraction, but the big magnets are having more power of attraction. That is wrong. Size of the magnet does not have any role in the force of attraction. The magnet is in smaller size also, it may have more power of attraction. So this is the smaller magnet. I have already shown that. See, this magnet is very powerful magnet. So it is very difficult for me to separate it. See, these are the two pieces of the magnet, but it is too difficult to separate this because their power of attraction is very, see, it's too difficult to separate because their power of attraction is very much. When you see this very small, isn't it? But the power of attraction of these magnets are very comparatively is very powerful. So the size of the magnet does not have any role in what? The power of attraction. There's another property of the magnet. Clear? Next one, we can discuss that sometimes we can make the temporary magnet. We can take an iron object. We can take, for example, I am taking this a small pin here, and you know this is the magnet. So if I want to make a temporary magnet, I need to keep this iron object close to that. Likewise, close to the magnet for long time, not for short time. I am supposed to keep this iron object here. This is the steel, but this is a coating only. Don't think that is a steel object because it is steel coating only. So if I keep this here iron material for longer time in contact with this iron magnet, you know what will happen? It will gain the magnetic property. So you can make a temporary magnet out of it. What we can make? We can make a temporary magnet. That means this object will act as a magnet for short period of time. When we keep these two in contact for long time, not 1 or 2 seconds, long time we are supposed to keep it. After a long time, then when we separate this iron object will act as a magnet. And we can say that this object is getting magnetized. What is that? This iron object is getting magnetized when we keep it closer for long period of time. So this is the first method for making a temporary magnet. But this temporary magnet, as the term indicates, it can have the magnetic property only for a short period of time. Afterwards, what will happen? Yes, it will lose its magnetic property. Clear? Yes, for a short period of time only they have their magnetic property. So the first method for making a temporary magnet. Another thing is that we can make temporary magnet by just striking this. See, just imagine this is an iron. Usually it is very easy to make the iron, iron. We are using it, but at present I am using this. Of course, this is also an iron object. So I need to stroke this. This is a magnet in one direction. If I stroke this in one direction for stroking is likewise. Yes, this touch and stroke. You see, stroke method. See, if I just stroke this for long period of time continuously. Yes, if I do this continuously for long period of time, very important thing you should keep in mind. You should do it only in one direction. If you do like this, please don't do it. Do only in one. You are not supposed to change the iron object also, but keep this in your hand and do it continuously for long period of time. That is stroking continuously for long period of time. Definitely this object will become a temporary magnet. That is a touch and stroke method. But in one direction, that is very important. You should stroke it in one direction. So two methods are there for making a temporary magnet. First one you have seen, when we keep an iron object in close contact with the magnet for long period of time, that iron object will behave like a magnet for short period of time. Next one, when we stroke an iron object by using the magnet only in one direction, after some time it will become a temporary magnet. Clear? So these are two methods for making the temporary magnet. When I say this, some of you may have doubt in your mind. How it happened? How this iron object will become a temporary magnet? You know that this iron object is having all the objects, they have the molecules. Our molecules are arranged. The previous chapter you had already studied about it. They have what? They have the molecules arranged. In the normal iron object, you can look at the board. The molecules are not arranged in a proper manner. That is arranged randomly only. The molecules are, just look at the board carefully. The molecules are not arranged in a proper manner. Randomly it arranged. മര്യാദയ്ക്കല്ല ഒരു പല പല രീതിയിലാണ് arrangement. But in the case of magnet, it is not like that. In the magnets, the molecules are arranged. Each and every molecule of the magnet, they are arranged in which direction? Who can tell me the answer? Yes, north-south direction. Not only the magnet, each molecule in the magnet also behave as if they are arranged in north-south direction. Very properly, very neatly arranged. So when we stroke an object, normal iron object, by using this magnet, what happened, you know? Gradually, the molecules of this normal iron object also will be arranged properly. ഒരുപാട് ചീത്ത സ്വഭാവമുള്ള ഒരു കുട്ടിയെ, ഒരുപാട് മിസ്ബിഹേവ് ചെയ്യുന്ന കുട്ടിയെ, when we scold, when we train that person continuously, sometimes or gradually that person's behavior also changes, isn't it? When we mold a person, when we mold a child, if child misbehaves continuously, when we just advise him, or when we just advise, not only advising, giving small punishments, gradually what happen, the child can behave properly. Similarly, this iron object also behaves in the same manner. You have already seen that the molecules are not arranged in a properly manner. But what happened when we strike it by using the magnet? The property of the magnet always, yes, it just passes to this safety pin. Here the safety pin, iron object. Then this iron object starts behaving like a magnet. Even this for a short period of time. So you can look at the board, see how the changes takes place. Gradually what happened? The molecules of this iron object, they will remain in which direction? North, south direction. So that is the organized manner. Clear? Yes. Then they also behave like a magnet. Next thing we want to study about the magnet, how to take care of the magnet. Magnets, if you keep it for a long period of time, definitely the magnets may lose its magnetism. That's quite simple. It can lose its magnetism. Clear? Yes. So to avoid that, we are supposed to keep the magnets in what? Yes. Opposite pole, like this. Opposite pole should be kept besides each other. North and south pole should be kept beside each other. It's two powerful magnets, so I cannot keep any pin or anything near it. It attracts it very fast. That's it. So that's it. So the magnets, both different poles of the magnet should be kept closer to each other. That's a simple tip for keeping the magnet. Second one, magnet should not be heated at all. You can look at the board. Magnet should not be heated at all. It can lose its magnetism. It should not be hammered. By using a hammer, please don't do that. The magnet loses magnetism. And magnets are not supposed to drop from the height. If we do so, it loses its magnetism. So kindly avoid these three wrongdoings to protect our magnet. This one, main thing, you are supposed to keep the magnets, or these two poles should be kept beside each other. Second one, then other three things that we are not supposed to do. Do's and don'ts, isn't it? Do's means what? Beside two poles, north and south pole should be kept close to each other. That's a two. What about the don'ts? Do not, yes, tell me, do not heat the magnet. It will lose its magnetism. Next one, do not, please don't hammer the magnet. It will lose its magnetism. Last one is what? Yes, you are not supposed to drop the magnet from height. It may lose its magnetism. We can't say that every time it loses, but chances are there for losing the magnetism. So these three things you are supposed to avoid if you want to keep the magnet safely. Clear? Then we are going to discuss the last session of this. What is that? Uses of magnets. Many of you already know what are the uses of magnet. First of all, magnets can be used in the toys, then telephones, in refrigerators, in different electrical equipments we are using the magnets. That you are already seen it. Second one, in ATM cards. Of you all know what's an ATM card, right? Yes, ATM card. So we're swiping, then we get the cash from the ATM counters. The ATM card is also having a chip that is made up of one magnet. Next one, the sailors. Compasses. In compasses, we are using the magnet because the sailors who are traveling in the sea, they do not have any landmarks. What's a landmark? A particular area to identify your. For example, if somebody asks you what's your house, you may say it Virinam or Bengaluru or wherever it may be. Then they may ask, will you please tell the landmark? Landmark means what? The famous place near it. Famous, maybe it may be a church, it may be a temple, it may be any business area, it may be a bank, anything. So you may say, my house is near, that near the bank, or my house is near behind the church. So we may say that. That's a landmark to make others understand very easily where you are staying or anything. So if you ask you, please tell me where's the post office, then somebody may say that it is near the bank. Then you can ask. Then they will show you the way. That's a landmark. Important place of important buildings. So here in the sea, definitely we all know that there is no chance for any landmarks. So the sailors, they cannot find the direction. So in such situations, they are using the compass. We know that the compass, the magnetic needle is there. It always points in which direction? Absolutely right. It is the north-south direction. It always points in which direction? North-south direction. So they can easily find out which direction they want to move. If north and south is that, definitely they know east and west. Am I right? Yes. So it's a very easy method for the sailors to find the direction while they're traveling through the sea. Kilometers and days they are traveling. So this compass will help them to find out the way. So another thing, if so many waste are there, you have already seen that, the waste may contain plastic, waste may contain iron objects, waste may contain rubber, etc., metal, etc. So when we touch the metal, sometimes we may get what, rusted metal, we may get some diseases. Hope you know about it. Want to take tetanus injection, so that's it. TT, if you touch any iron object, especially rusted, we may get that tetanus. So we are supposed to take the TT. So here, so to avoid to separate the metal objects from the waste material, people are using this magnet. So the magnet, they can easily attract the magnetic objects very easily. But when I keep this closer, will it attract? No, it's a paper. No. So very easily the small magnets are not used in such a cases, because objects may be very big. Sometimes after the buildings collapsed, or when they wanted to restructure the buses, cars and all, they want to separate the different parts and all. So they want to carry different areas. So in such a situation, situations and all, it is not easy to carry it from one place to another by using the hand and all. No, they may get rest, and sometimes they may get injury and all. In such a situation, we can use these big magnets to separate this iron object from the waste material, or carry iron objects from one place to another also, want to keep in the lorry or somewhere. Instead of holding it in the hand, the workers are there definitely. So to reduce the workload, we can use the magnet, so they can lift these objects and they can separate it. Clear? Okay. So next, I would like to give you some tip for understanding whether the steel object is good or not. Just okay. I will show you that now. See, I will show you two bottles. Two are steel bottles, isn't it? Both look good. Okay, so let me see whether these bottles are pure steel, or if it has iron content or not. Irumbundo, we want to check it. Okay, so first of all, I would like to take this Okay, see. See. So from this I can understand that you see no attraction is there. See, whatever I touches this, no attraction, because this is made up of pure steel. This is a good quality steel. Clear? Yes. See, this bottle is also a steel bottle. See, I could see that a small force of attraction is there. So I will show this very clearly. Yes. See, it has a small force of attraction. Yes, not like the previous one. It has a small force of attraction. Wait for a second. See, there's a small force of attraction. From this we could understand. Everywhere I could feel that a force is, yes, pulling me towards it. A force is pulling me towards it because it has got a small power of attraction. So from this I could understand that this steel is not very pure. I can't say that it's full of made up of iron, but that is comparatively lesser, some iron content is there. So if you want to buy, steel objects from the shop, so if you are going with your parents or mother, then you can check it by using a small piece of magnet. If it gets attracted towards any steel, you are buying the spoons, you are buying the steel plates and all, different steel objects we are using. So if you want to find out whether it is good quality steel or not, you can use this magnet. If it attracts, definitely we can understand that that is not a good one. If the magnet doesn't get attracted towards it, then understand that that is impure. Okay, if this it attracts, it is impure. If it does not get attracted, it is a pure steel. Understand? Okay, children. So now we have discussed about the different properties of the magnet, and in last class, hope you remember, I had already told you how the iron filings get attracted towards the magnet. So now you can watch a small video. I will show you that how it works. Okay, dear children, yes, this is a piece of magnet. Okay, hope you have seen it. So, and now you can observe some iron filings are there. Clear? You can observe the iron filings are there. So just when I just hold this magnet here, see what happened. See, yes. See, it is getting attracted. See, yes, this magnet is getting attracted towards the iron filings, and just I'm trying to move the mag. See, how beautifully they are getting. See, yes. When I bring that closer, 1 second, please. See, the magnetic power is moving from north to south direction. See how it get attracted. See. Hope this is very clear. So when I just move it away from it, no magnetic power is there. So now we can just observe what is happening. See, yes. From this, what do you understand? Yes, magnet is just close to that. It's a non-magnetic material. That's very, very clear. This material is a non-magnetic material. But as I told you earlier, it can attract. See, yes. See the movement of the iron filings. Wow, right? Yes, so here the movement is from north to south direction. Hope you can see it. So just hold this. See, yes. See, yes. Just have this iron filings attracted. Full push. See, this full mag and filings is here. Hope it is clear. Okay, children. Okay, thank you. Okay, hope you have seen it, how the iron filings, how it get attracted, and it's very beautiful to see, right? So now we can just summarize what we have studied today. First one, we discussed about the, when we cut the magnets into different pieces, each magnet will have what? Each magnet will have? Yes, North Pole and the South Pole. And even though if we cut in smaller pieces also, no change in it. Next one, we had discussed that the poles of the magnet, they are more powerful. Next one, we discussed that what? A magnet should not be in close contact with the magnetic material. Yes, to get attracted. So you have seen through a smaller experiment. Next one, but as the distance increases, power decreases. That's it. So next one, the which type of magnet is more powerful. Don't think that smaller magnets are having less power. It is strong. Size of the magnet does not have any role in it. Size changes in the smaller magnets also have got what good magnetic property. Next one, you know how to make temporary magnets. First one is part by keeping the iron material close to the magnet for a long time. Iron will behave like a magnet for short period of time. Then in that way we can say that is getting magnetized. Last one, in the second method is that when we stroke the iron object by using the magnet in one direction for long time, that iron piece will become a magnet. Clear? Yes. Next, then you know how it happened. It's because when we strike the magnet, the molecules in the iron object will remain arranged properly, that they behave like as if they are in north-south, north-south direction. The molecules, they are arranged in an orderly manner. Then we discussed about the use how to take care of the magnet. Different methods are there. First one, we are supposed to keep the opposite poles of the magnet beside each other. Second one, then don't drop the magnet, don't hammer the magnet, don't set fire the magnet. This should be avoided. Next one, uses of magnet. You have already seen that. First one, in toys, refrigerator, etc. we are using the magnet. Next one, in ATM cards and the sailors, they are using in compasses for finding out the direction. Next one, we know that for separating the iron waste from the different ways, you are supposed to separate the iron by using the magnets. So with this we come to the end of this chapter. Now we can discuss the 2 or 3 question answers balance. Then we can discuss that now. Okay, now take the textbook. Yes, page number 185. See 182. We can just go through that to fill in the blanks once again. First one, which of the following metal is magnetic? Iron. What happens when a bar magnet is suspended freely? Yes, it will always remain in the north-south direction. Next, third question, what is the magnetic strength of a magnet concentrator? Yes, at both the poles. Which of these materials can be used to make a temporary magnet? What? A piece of iron. Which of these actions will result in the loss of magnetism of a magnet? Yes, hammering. In which of the following devices magnets are used? In ATM card. Next one, true or false? Magnets attract all metals. Is it true? No, false. A freely suspended bar magnet remains in east-west direction. Is it east-west direction? No, north-south direction, so it is false. The poles of a magnet can be separated. Can be separated? Absolutely no, false. A magnet can attract or repel from a distance. True. Non-magnetic materials allow magnetic force to pass through them. Yes, that is very clear. When I kept the magnet in the, in the paper cup, you had already seen it. Even though it is a non-magnetic material, but through that it can exert the magnetic force, isn't it? When I keep the magnet inside it, when I keep the pins or safety pins here, you have already seen that they both get attracted. So in certain situations, they can also act as what? Non-magnetic material. Where magnets can never lose their property of magnetism. No, false. It can lose by doing hammering, by setting it to fire, by dropping it from the height. The power of the magnets can be lost. Next one, where will you find the maximum magnetic force in a magnet? Yes, it has a poles. How should 2 magnets be stored to avoid losing their magnetism? Section 4, question number 4. They should be, yes, opposite poles should be kept beside each other. Then we can avoid that. What will happen if a bar magnet is cut into 4 pieces? Question number 3. What will happen? We will get what? 4 different magnets, isn't it? With north and south pole. When we cut the magnet into 5 pieces, we will get how many magnets? 5 magnets having north pole and the south pole. We will not get a magnet having the north pole alone or a south pole alone. We will get the magnet, even the smallest piece also, it will have what? North and the south pole. How is a compass helpful to sailors? We discussed it so many times. Because the compass, inside the compass, the magnetic needle is there. They always suspend in which direction? North-south direction. So north means what? Geographical north. South means what? Geographical south. Then magnetic what? Yes, magnetic south and magnetic north. What happens when a permanent magnet is kept in contact with an iron nail for many days? it will have what happened? It will become a magnet, and we can say that the iron nail is getting magnetized. Explain with an experiment that a magnet attracts a magnetic object without being in contact with it. We've already seen that by keeping an magnet inside a paper cup or plastic or anywhere, we can keep some iron filings or steel or iron objects. You can see that they get attracted to each other. List 3 ways by which a magnet can lose its magnetic strength. What are the 3 methods? Yes, by heating, by hammering, by dropping from the height. State in 3 uses of magnets. They can use in the toys, refrigerators, etc. They are using in the ATM cards, magnetic strips. Next one, it can be used by the sailors. Okay, in the compasses, we have the magnetic needle. Describe how a piece of iron can be temporarily magnetized. 2 methods are there. First one is what? Yes, tell me the answer. Yes, when we keep the magnet with the iron nail for a few days, the iron nail will become a magnet. Next one, when we stroke the iron nail by using the magnet, then it will become a magnet. The needle of the compass, HOT, higher order thinking skills. The needle of a compass always points north-south direction. Why? Yes, we know that geographical north of the earth is magnetic south and geographical south is the magnetic north. So, in this manner, we can understand it. We can understand the distance. An iron strip becomes magnetized, but a plastic rod does not. Iron strip is a magnetic material, while the plastic rod is a non-magnetic material. 2 magnets, if brought close to each other, either attract or repel. Like poles of the magnet repel, and like poles attract. Magnets must be stored with their opposite poles beside each other. Then they will, what will happen? They will get what? Attracted. So we can keep it for a long time without getting, without losing their power. Okay. So I hope this chapter is very clear, my dear children. Am I right? Yes. So next week onwards, we do not have any video classes like this. Instead of that time you can receive the audio clip through the WhatsApp, that we can start revision. Clear? So hope this will be the last video class that we are having. Definitely we will have online discussion sections afterwards. Okay, online discussion we will have, but the video classes, it will be it's a last video class for you. Next week onwards, you will listen the audio clip. That means the revision will be conducted. Okay, through the same time you will receive the audio clip. Then test papers are there afterwards. So get ready for the test paper. Complete the notes regularly, and just if any doubts are there, you can contact me through WhatsApp, or when we have the online discussion session regarding the clarification. So that time also, please before that, kindly let me know what are the doubts you are having from which chapter. Clear, children? So be safe until, okay, I cannot say until we meet in the next class, until we meet in the next online class. Okay, till then, bye bye. Take care, my dear children. Bye.